Hello and welcome to this lecture where we are going to continue the implementation of single tracking. Just a reminder that last lecture we implemented these codes to select the algorithm we want to use. And in this lecture, we are going to read the video that we are going to use as example, and then we will select the object that we want to track. I will create a new folder here, new directory. I will call the name of the folder will be videos, and you can access the course materials and copy and paste this file race.mp4. Let's click OK here. Inside this folder, we will store all the videos that we are going to use in this course. You can see the video here. The goal is to select the objects or the runners, and then we are going to track the runners until the end of the lanes. And the first step is to load the video. I will create a new variable, video, cv2.video capture. This is an OpenCV class to load videos. And now we just need to specify the path. Videos, it is the name of the folder with V in capital, race.mp4. Now we can just check if the video was correctly loaded. If not, video is opened. If it wasn't possible to load the video, then we can print an error message. For example, error while loading the video. And then we can just type sys.exit to finish the execution of this code. Sys is this import that we made in last lecture. We can just run this code to perform the first test. We can see here the name of the trackers. We can also put these two prints in comments. For example, if we change the name here to an invalid name, see that we have this message, error while loading the video. If this message is not shown, it means that the video was correctly loaded. Now we need to get the first frame of the video to select the object we want to track. I will create two new variables, OK and frame. The OK variable will indicate if we could load the first frame of the video. On the other hand, the frame variable will store the first frame of the video. Now we can type video.read. It will read the first frame. We can also type here, if not OK. If we couldn't load the first frame of the video, we can print again an error message. Error while loading the frame. And then we can just type sys.exit. We can print this variable here, OK. It will return true or false. True if we could get the first frame, and false if there is one error while loading the frame. Let's run this code. See that true was returned here. So it means that we could load the first frame of the video. Now we will define another variable, bbox, which means bounding box. This variable will store the positions of the object in the first frame. And to select the object, an OpenCV function, which is select ROY. And we will send here the first frame. ROI means region of interest. Now we can run this code again. See that a new window was opened here with the first frame of the video, the first position. And we can see some messages here. Select a ROI and then press space or enter button. Cancel the selection by pressing C button. If you want to cancel, we can just type letter C. We can see that the process was finished. Let's run this code again. Now we can select the object. For example, we can just draw the bounding box in order to select the object we want to track in the first frame. This is very important when working with tracking algorithms, that when you have a video, first you need to select the object in the first frame. If you click outside the bounding box, you can select another object, and to confirm the selection, we can press space or enter. For example, I will press in my keyboard space. See that the process has finished. Because actually this code is only selecting the object. We are not tracking the object yet. And we can also print this variable bbox. Let's run again. I will select the runner, press enter. See here that some positions were returned. The first is the x-axis, the second, the y-axis. It means the coordinates of the bounding box. And here we have the size of the bounding box. Let's run this code again. For example, if I click in this part here at the beginning of the image, let's select this region here, press enter. See that position X is pixel number 4 and position Y is pixel number 3. It's at the beginning of the image. And see here that these other values are lower than the other ones because we have a smaller bounding box. Let's run this code again and select almost the whole image here. We have this big bounding box. Take a look at the positions, X and Y axis, and this is the size of the bounding box, the width and the height. So in short, this variable here will store the position of the object we want to track. Now we can recreate the OK variable. Let's call the tracker.init, and I will send here the frame. This is the first frame of the video, and also the bbox variable. Now we are initializing the algorithm. Take a look here that the tracker that we are going to use is number 6, which is CSRT. We can change to boosting, which was the first one you learned the intuition. So now we will create a boosting object. We will use this algorithm to track the object. So in this part here, we are initializing the boosting algorithm, and we need to send the first frame and also the position of the object we want to track. We can print OK here. Let's run these codes. Select the runner, press enter. We have here the information about the bounding box, and this message true indicates that the tracker was successfully initialized. Finally, we will define another variable, colors, equals, let's call the function we imported before, randint. We will generate random numbers between 0 and 255. Randint 0, 255, and finally randint 0, 255. Let's print this new variable, colors. Run this code again. We need to select the objects. See here that we have these values, which will be used to define the color of the bounding box. As we are using a random function, every time we run this code, we will have a different result. See that these values are different from the others, and we are defining 3 values because the pixels of the images are composed of 3 channels. One channel for the color red, one channel for the color G, and one channel for the color B. This is the RGB format. Just to better understand, we can use these 3 values in this RGB calculator. For example, we can type 17, the first number that was generated in channel R, 105 in channel G, and 165 in channel B. We can see this color here that was randomly generated. This is the RGB format. However, OpenCV works in the format BGR. The first channel is blue, the second is G, and the third channel is R. So, to get the color that will be generated considering these numbers, we need to change the order of the values. For example, R is 165, G is 105, and B is 17. We have this color here. So, these numbers will create a brown bounding box, and we are going to define these random colors because in next lectures we are going to implement multi-tracking, so we can track more than one object in a single video, and each one of them will have a different color. And in the next lecture, we are going to finish the single tracking implementation, and we will also see the results. See you there!